A developer was checking her CI/CD logs one Tuesday morning. Her builds were running slower than usual. Network traffic seemed off, way higher than it should be. She pulled up the dependencies. One GitHub action stood out immediately. It wasn't on any official list. Digging into the code, she found something shocking. Hidden miners, cryptocurrency miners, actually running on every single build. Not just one, every build. For 2 million developers trusting this utility. 2 million. Every week, it was executing in their pipelines, silently consuming their compute resources. The code was buried deep, obfuscated intentionally. Someone had spent serious time hiding this. This wasn't an accident. This was planned. What started as a simple performance check turned into uncovering one of the largest supply chain attacks in GitHub history. 2 million downloads every week. That's not niche. That's not a tool a handful of developers experiment with. This was running inside the CI/CD pipelines of Fortune 500 companies, the ones building financial systems and cloud infrastructure. Universities worldwide used it in their research projects. Startups integrating it into next-generation platforms. A single compromised dependency meant automatic propagation. Every build that ran, the malware executed. Every deployment pushed it deeper into production. The attacker didn't need to hunt victims. Victims came to them through trust. GitHub Actions automate everything in development. Broken builds? Fixed in seconds. New features? Deployed instantly. This tool had earned enough credibility. It sat at the center of trusted infrastructure. No human ever reviewed the actual code. No security team challenged its presence. It was just another optimization, just another trusted utility. When a developer added this action to their workflow, nothing looked wrong. The code was clean. The documentation was detailed. But buried inside, it did 3 things at once. First, it scanned the runner for GPU access. Found it? Launched a Monero miner in the background. Silent. Low priority process. Your build still passed, but it stole compute cycles. Thousands of machines, each one printing money into the attacker's wallet. Second, it hid the evidence perfectly. Real compiler logs, real test output, mining data buried inside the noise. GitHub showed green. Passing build. No warnings, no alerts. Third, it cleaned up after itself. Logs rotated daily. Temp files deleted. A developer reviewing that runner would find nothing suspicious. Just trustworthy code. 2 million times it ran. Every single execution extracted value. The genius was exploiting pure human trust. When you pull a dependency with millions of downloads, you assume it's been vetted, scanned, safe. Nobody's reviewing 50,000 lines of minified JavaScript. That's where the attackers lived. They obfuscated the payload beyond what static analysis tools can catch. Traditional security scanners hunt for known patterns, keywords, signatures, suspicious API calls. The actual mining logic was fragmented across layers. Base 64 strings, dynamic evaluation, obfuscated network calls, runtime decoding. Even if a tool flagged something, you'd see random hex, not mine crypto here. The library name itself was absolutely crucial. It mimicked established packages so closely that typos seemed intentional. Developers saw the download count and assumed maturity, assumed testing, assumed safety. That assumption killed detection. The payload stayed invisible for months, completely hidden in plain sight. But here's what actually matters. This wasn't about electricity bills or free compute. One compromised GitHub action gave attackers shell access to thousands of build servers. From there, they could have stolen source code, intercepted secrets, modified package dependencies before release. Watch what companies are building. The entire open source supply chain just became a staging ground for espionage. Think about it. If you're using this action, your CI pipeline ran attacker code. That access doesn't just vanish. It creates backdoors. It enables lateral movement into internal networks. 2 million downloads means millions of potential entry points. Not for stealing CPUs, for infiltrating companies, for understanding what's being built before it ships, for stealing intellectual property at scale. That's the real threat. This wasn't a mining operation. It was reconnaissance. Stop waiting for your CI/CD to fail. Check your dependencies right now, especially GitHub actions used in builds. Look for unknown commits, recently active accounts, anything updated without your approval. Ask yourself, when did this dependency last change? Enable code, signing verification on every single workflow. Your build should fail if signatures don't match. This is your last automated checkpoint before code hits production. Watch your logs like you mean it. Unusual network activity, crypto mining libraries, unexpected system calls. These aren't random. They're breadcrumbs left by attackers testing your defenses. This attack pattern is the template for what's coming. Next is ransomware in your deployment pipeline. Then credential theft. Then persistence mechanisms buried deep. The supply chain isn't getting safer. It's becoming the standard attack vector. Your move is now.